All right, here's what I've got for you. If if the radical is a odd root, I'll try and write that a little bit bigger. It's an odd root, then we don't have to worry about any of the absolute value stuff. So let's say we have cubed root of x to the 10. I'm going to rewrite that as the third root, the cubed root, x to the 9 with one x left over. And I've chosen x to the 9 simply because I can do 9 divided by 3 nicely. So 9 divided by 3 is going to give me x to the 3, and there's one x left over. So that would be our solution. And we don't need to worry about the absolute value sign. Try and move that a little closer. There we go. All right, so and that's it. We're done. So if it's an odd root, an odd radical, no worries. If it's an even radical, like the square root of m to the 11 or the square root of n to the 9. So those are two different examples where we have an even radical. Where a square root is like a little 2. We don't write it, but it really should be there. So I'm going to rewrite this as a square root of m to the 10 with one m left over. That's 11 m's altogether. I'll write this as the square root of n to the 8 and one more n. Again, because of that little 2 that we don't write, but it's there, I can do 10 divided by 2. Here it was 9 divided by 3. Here it's 10 divided by 2. So I'm going to get m to the 5 with one m left over. And with this one, 8 divided by 2, 4, n to the 4, with one n left over. Now we got to talk about absolute values. This is an even root, an even radical. If, after you've done the division, after you've simplified m to the 10th to be m to the 5th, if you've done that simplification, if your exponent, your remaining exponent is odd, so if it's odd in the end, you need to put absolute values. If it's even, you don't. I'll do two more examples, but that's how you tell. After you've done the simplifying, if you get an odd exponent out here, then you put those absolute value bars. If you get an even exponent, then you can leave it alone. It's because a negative times a negative is a positive. That's why the even makes a difference. So two more examples. Let's say I have the fourth root of m. We'll go to the 11 again. This time I'll do the fourth root of, say, n to the 13. All right, so I'm going to break this into something. Now I'm not going to do m to the 10 because I can't do 10 divided by 4 nicely. So I'm going to do m to the 8 because I can do 8 divided by 4. And that would leave me with 3 m's left over. 8, 9, 10, 11. Yep, 3 m's left over. Similarly, 13, I'm going to do n to the 12 because I can do 12 divided by 4 nicely. And there'll only be one n left over. Okay, 8 divided by 4 is 2. And then I would have 3 m's left over, m to the third, still inside that fourth root. For this one, 12 divided by 4, n to the 3. And I'd have one n left over inside the radical. Okay, I'm going to do the same odd and even thing. This is an even exponent or an even root, even radical. So I have to worry about absolute values. In the end, this was an even exponent after I finished my simplifying. So with an even exponent, I'm going to leave it alone. And that's the answer. After I've done all my simplifying here, I have an odd exponent outside. So I do need to put those absolute value bars in there, because in the end, after my simplifying, there was an odd exponent. And that's how you tell. Odd radical, no issue. Leave it alone, no problem. Even radical, 2 or 4 or 6 or 8, do the simplifying. And in the end, whatever you get, if it's an odd exponent on the outside here, put the absolute value bars. If it's an even exponent on the outside, then you leave it alone. I hope that helps. Let me know if you have more questions.